Hello. Hi, Gavin.
Hi, Emily. How are you? Thanks for inviting me along today. Yeah, good. It'll be good to speak to you. Yeah. Hi.
Thank you so much. Thanks for joining the podcast. I really, really appreciate that. I'm really looking forward to asking you some questions to draw out your expertise and your knowledge in the technologies that you work with.
Mhm.
So, if you could start us off with introducing yourself and what it is that you do.
Sure. My name's Gavin Olukoju. I'm the director of a company called Inconnect Systems, and what we do is put in intelligent and novel solutions that are bespoke for customers. So our approach is really sort of understanding what the customer is looking to achieve, and then providing a digital solution that meets that requirement. That is a good fit, really. So yeah, we do a lot of software development and consulting work in the sort of digital space.
Amazing. No, that's great. And how have you got to where you are today? Is there a bit about you sort of how you sort of progressive in your career, what you started out as, and then and different technologies that you've worked with, just to get an idea.
Sure. So, like all of us,
Mm.
we all get our experience from, work we've done previously. So, went to university, did the whole computer science degree, and so on, and then from there, worked for various companies as a developer. So this is framed in the context of about 20 years worth of experience. So worked for various companies in different business domains. So that was telecoms, banking, e-commerce, and then set out on my own as a contractor. I've gained experience on working with lots of different projects over government and retail and banking and telecoms. And yeah, now it's really taking the next step in terms of working with customers directly, of which we've had a few great ones. And yeah, just really looking to sort of evolve from there. So one of the advantages of that is that
Mm.
I've got that technical understanding. So I am technical. I am a techie by nature. Um,
Yeah, great.
so it's one of those things where I can actually understand a fundamental level how to solve a challenge for a business. Um, and when I'm working with teams or directing teams on projects, I can actually understand and propose things that are feasible and are working. And from having experience with different businesses, you can understand the sort of different challenges they face. And yeah, yeah,
You've
that's
got a
kind of
wealth of
the value that I add.
experience.
Thank
No,
you.
definitely do. Yeah, thank you. And you've got a real solutions approach. I wanted to touch on that as well, like how you go about, finding the solution with a customer. What would be your usual sort of approach for that?
Absolutely. So for our approach, it's more solution first, technology second. So we kind of listen to the customer, understand what kind of challenges they're facing or what they're looking to aspire to do, um, and then we'll work with them, make sure that there's a user design that's appropriate and that it meets their use case, and also any sort of compliance and regulatory requirements as well, because things like GDPR, PCI compliance, and how to manage the data associated with their system. So we make sure that's all covered. We then look to sort of see what infrastructure they currently have in place. So often it's not always needed to replace a existing system with a brand new one. Whilst that may be appropriate in some cases, there's challenges associated with that in terms of data migration, data integrity, decommissioning things. So a lot of systems now you can extend them in a way so that they can work in ways that they weren't originally designed to do, such as with mobile apps or putting data into other systems and that kind of automation. So looking at the current infrastructure they have, and then recommending a technology solution that meets both their user and business aspirations, their current technology landscape, and then putting in something that fits really.
Yeah, no,
So
I really like
that's
that.
kind
It's
of the
not.
order we do things, and it works pretty well. Yeah.
I like it. Yeah, it's not just like a one product fits all. It's what are your pain points? How can we then provide that solution? And it's for them, isn't it? It's going to suit what's
Absolutely.
best for them.
Absolutely. And it adds a
Mm.
lot of value as well because, rather than thinking, okay, well, we need to throw away this system that we've invested a lot of money in, you can kind of extend the lifespan of those systems if needed and get more value out of them. And also, you can get value from efficiency. So, often in businesses, there's a lot of cross typing where it's like, if I'm to do this business process, I need to then type information into this system A. get a result from system A, then type that result into system B, and there's a whole chain of manual operations, or we keep our information on this particular thing in this system and this information in another. And we can put in solutions that can bridge the gap between these systems and make users more productive by having fundamentally less work to do. Basically, getting the software and infrastructure to work for the user rather than the user having to sort of understand and learn and manually go through processes to work with the environment that they're in.
User interface, yeah, no, that's amazing. Thank you. And you've got some really interesting projects that you've worked on, and I was having a look through your portfolio. But could you touch on maybe perhaps one of those applications and go through sort of the application project that you worked on there?
Absolutely. So one of the case
Okay.
studies on our website is one for Siemens, and this particular project was where it's a bit of software called Capital, and they design vehicle harnesses. So what a vehicle harness is effectively a cable that's routed through the vehicle that talks to various subsystems within the vehicle. So, be it an ECU, a body control unit, speakers, lights, door locks, all those kind of things. They're all connected via cabling. So this capital software enables an engineer to understand the chassis of the vehicle, look at the requirements. So if it's uh, exposed to the elements, you've got waterproof connectors. If it's inside the vehicle, you've got different types of connectors for different currents and different environmental things. So that is what the capital software does. That's a desktop application, but then that application exports a file um, that engineers use in a field. So when and the capital software not only works for cars, they also cover vehicles like aircraft and boats and other things as well. But one of their main things is for vehicles, and it exports a file that traditionally was run on a laptop because the content was hosted on a web server and it needed an internet connection, and it needed a desktop web browser to run. Now, whilst that's a good solution, it's not necessarily an ideal solution in some circumstances, because when you're working under a vehicle or you're working in a confined space in an aircraft, a laptop is quite a cumbersome thing to deal with. It's clamshell format. You find it hard to rest it, put it down places. And also, with it being a web application, you need to have a good internet connection. And often in garages, there's a lot of metal around. It's basically like a Faraday cage, or even if you're inside a vehicle like a boat or an aircraft, you're surrounded by metal. So it's very difficult to get a Wi-Fi signal in, and also it's not very practical to have hundreds of meters of cable just so you can have an internet connection. So a laptop isn't necessarily the best solution. So when we came on board, we understood the export that was coming from this capital application that the engineers were going to be using, and the customer had an aspiration to have this all working on an iPad. Now, traditionally, a lot of organizations will say, okay, well, it's just a web application, we'll just put it on an iPad. But the challenge with that is still the internet access, and you've got that
Mm.
latency. If you're working and diagnosing a system, you want to work quickly, because as an expert, there's a lot of things going through your head. You kind of don't want to be waiting for the system to give you that extra information that you need. So it's better to have that information locally. And also, with, as I said before, the internet connectivity can be questionable. So what we did was found a way to effectively write what's called a web server on the iPad. So effectively, you could have that web access locally. We could use the export format from this capital application, and actually understand that file and host it in as a web. Um, uh, so it could be run within a browser. But not only that, we developed it as an application. So the browser was the application. So you didn't have to go to a web page on the thing. You would just open up the application, and all the information you needed was there. And that was really, really good because one, they had all the information they needed. They got to where they needed with an iPad. So again, when they're in the field, depending on the space you're working in, you could have like small iPad minis or full size iPads. It didn't really matter. It worked on any. In fact, it even worked on a phone.
Amazing.
Um, there were
Oh,
some UI
wow. Mm.
constraints because it was sort of a bit small, but fundamentally it would work on a phone as well.
Great.
But yeah, that was a really interesting and
It
enjoyable
fascinates me
work.
that you can obviously access the internet from anywhere, and it can be in a really remote location where, a vehicle needs to be worked on and they can use the application to do
Absolutely.
that. So
Yeah, one of the use cases
yeah,
they did mention was, aircraft in like the Nevada desert where, aircraft might be going off for some maintenance and you're literally in a desert, in a hangar in a desert working on their aircraft. So yeah, internet
interesting. Yeah.
connection can be a bit sketchy, even mobile connection, because you're just
Yeah,
in the
mobile as well.
desert.
Yeah, well, it solves
Yeah,
that problem, doesn't it?
very much
So
so.
what do you use to develop this? So to develop this web server, what sort of technology do you use to make that, to
Sure.
build it?
So for that particular use case, it was built in Swift because, and the reason Swift is a programming language for iOS. So the
Mhm.
reasoning behind that was it was only going to run on an iPad, and to get the best performance, it made sense to use the native programming language of the operating system so that you got the best performance and you had that better integration. But as a business, we will use any language that's appropriate. So, of course, from me, I come from a Java background, so I can see things in Java, but we can develop solutions in Python. For mobile development, we're taking a strategy of using Dart and Flutter, which is a cross-platform native mobile application framework. And for a lot of use cases like retail or business operations, it works really well because it gives you that flexibility of being able to have one code base that can target both Android and iOS. And even now, it can be extended further to Mac and Windows, which makes for some really interesting applications, such as kiosk apps in store. So you could have hypothetically, maybe a hotel application where you can have a kiosk and a user can fundamentally go and book a room or request services from that hotel, like get a taxi or what have you, just by interacting with an in-store kiosk without having to necessarily go to the concierge desk. Um, Again, another use case could be in a retail location where hardware stores like B&Q and so on, often it's quite a challenge to find customers when you're looking for specific things. You might need a bit of pipe or
Mm.
like a hammer or something like that, and you don't know which aisle it's on. So if you've got kiosks in strategic locations within the store, a user can then go in and query and saying, "I'm looking for this particular tool," and it can tell you where in the store it is, or if it's in stock, or even transact on that and say, "Well, I haven't got time to go and manually walk and search for it. I'll just place an order here and have it delivered to my house." So there's a lot
Amazing. Yeah.
of interesting applications you can do. Um, but that being said, whilst technology is good for those kind of things, I'm not a fan personally of just only interacting with robots and touchscreens. I think,
Yeah, a balance. Yeah.
yeah, there needs to be a balance, and I think it'll be good for these devices really to take over the more transactional elements of retail or hospitality or things like that. So, in those kind of scenarios where you want something done quickly and you don't necessarily need that human interaction, you're going into a hotel, your train's been cancelled, you're frustrated, you just go, like, I just want a room, I don't want to speak to anyone, I just want to, you know, get to bed
Well,
basically.
again, it just
Yeah,
improves the service, doesn't it? The quality of the service that they're getting. So, like you say, they're perhaps avoiding a queue at a hotel,
very
or
much so.
there's the efficiency of trying to find an object, so you're not actually wasting members of staff time as well. The
Absolutely.
whole thing is a lot more efficient, and the customer comes out with having experienced it a lot better, and
Absolutely.
more likely than to return. So,
Very much
yeah.
so. And also, by doing that, it frees up for better customer experiences with those human interactions. So you can have, in a retail location, more consultative relationships with your customers. So if someone's going into that retail store, they may be or like a hardware store, they may be thinking, oh, I'm considering getting a new kitchen. And because that is going to be more consultative. You can say, oh, well, have you considered these doors? Have you considered the furnishings, the colors, the fixtures and fittings? And people can talk about that more, and it frees up your staff to have those more meaningful and consultative conversations, rather than just saying, oh, go to aisle 12 and row.
Yeah,
You can have better conversations, and again, customers will return because you're getting that better customer experience. You're offering both,
that
but
customer, yeah.
delegating the more transactional stuff to the machines.
No, that's great. Thank you. And what are your thoughts on what you predict in terms of technology for this year? What are you seeing that's a popular trend? And I also wondered what your thoughts were on sort of like data manipulation and AI, artificial intelligence.
Mhm. I think AI there was a lot of hype, I would say. AI is incredibly useful. It's good at when it's trained properly. I'll put that caveat in. So,
Yeah.
the one thing I'm finding is that data has always been a thing. It's becoming more popular, and this data that people are focusing on in terms of analytics and metrics, and also customer service data in terms of customers interacting with businesses. All of these sources can be used to train an AI model for analytics. So you can do predictive analytics. So you can say, based on last year, over the summer, we sold more ice cream, and we predict in July we're going to sell more ice cream than we would do in March. So you can get a rough number based on various factors like location, an area, and demographics of an area, and so on. So you can use that to do predictive analytics on sales, for example. Um, but when you've also got the advent of chatbots as well, and these can be used from customer service data, where you can say, okay, when we've had feedback through a website or interacting with people, we've got recordings of the chats that people have, and we can use that to program or train a bot on appropriate responses. But the key point is, it's the easy part is training a machine on that data to give a response. The challenging part is having that machine give the correct response for a given situation. And I won't name names, but there was a recent article where it was to do with a postal service, a courier service, where the chatbot, a customer would go in, was complaining about the location of their parcel, and the level of service they were getting and how it wasn't meeting expectations. And the chatbot empathized with the customer in not a way that in a way that wasn't positive for the business. So it started
Dear.
berating
Yeah.
the company that it was working for, going, "Oh, you're absolutely right. This company is no good. You should take
Oh
this away."
no.
And so
Oh
the
no.
empathy part was correct, but as a business owner, you don't want to, you wouldn't have your employees saying, "Yeah, this is a terrible company to work for. I wouldn't recommend you do business here." Um, but that was
You'd be so
because it was,
careful.
yeah, that was as a result of the training, where it had been trained, but no one had given it any oversight really to say, you need to empathize with the customer, but you also need to give them a constructive response, and not
Mm.
attack the
Is that
organization
validation,
you're
is
working
it?
for.
Is that what, so you need to validate that a bit more, that particular chatbot?
Absolutely, absolutely. So all a neural network is, which a lot of these chatbots and chat models are a series of inputs and weightings. So the weightings are basically will adjust the probability of a given answer in a most simplified term. Um, so based on these inputs, the most probable appropriate output is that answer. So, as well as training it, you need to have a good test harness around it with sample conversations that still need to be reviewed by a human being fundamentally. You can automate some of it, but fundamentally, you still need to have a human being in the loop to say, if we give a machine this input context, what is the output? And if it's not correct, you can then reinforce it on a correct answer. So you can give it more examples that it's giving the wrong answer to, and then train it to say, when you see this scenario, you need to give this answer. So it's just, and that's through gathering more data or generating more data that it matches the sort of the edge case or the incorrect response
To
um,
test it
to
in
the
different,
question. Yeah.
yeah, I see that
Um,
testing environment.
and one thing I'm seeing in
Okay.
in the media and the hype around AI, there's no real conversations around making sure that the AI is giving an appropriate response to a given scenario. There's a lot of excitement around, oh, we can have it read all our data, and it can, we can use less customer service personnel to do things. But I think it's the harder part of it is making sure that the AI is giving an appropriate answer. And also,
Answering it.
another thing with AI is using AI for the right reasons. So generally, you would use AI for what's called a non-deterministic solution. So what I mean by deterministic is when you've got rules. So if you're how can I put it? Making a sandwich, for example, this is probably going to upset some people, but you have your slice of bread, you put your butter on it, you put your sandwich filling in, and then you put the other butter and bread on top, and that's how you make a sandwich. And you can kind of, there's rules to it, and generally, it's bread with a filling inside. So you know that is an example, I suppose, of a deterministic problem. Something that isn't deterministic is kind of like what Tesla is doing with driving, where you can't easily write rules for every single road a car could possibly drive on. So it's like, if you're on this road, then drive at this speed, turn at this angle. If you see this, then do that. That becomes an insurmountable problem because there's so many options and inputs that it's going to be very, very hard for a programmer to do it, or you're going to need an army of programmers working for hundreds of years just inputting all those rules. And
Mm.
that's what's called a non-deterministic problem. So fundamentally, it, AI is better suited to that because you're giving it lots of examples of um, a scenario, and then telling it what the appropriate response should be, rather than
Friction,
explicitly
yeah.
saying, if you see this, then do that. And I
Mm.
think there's a risk that AI can be used in a lot of deterministic problems when it doesn't need to be. And
Doesn't need to be, yeah.
yeah, and
Mm.
the problem with that is you can have unpredictable results in exactly the case of that customer services problem, where you know you have a customer complaining, and the correct part was it empathized with the customer, but it then agreed to the point where it's detrimental to that business, which is not the appropriate response. Um,
No idea. Yeah.
Also, another
Okay,
thing.
that's a
Also, I'll wrap up on AI,
mm.
but one other thing is
Yeah.
these models need constant training. Um, so as you get more data and new data, these models need to be retrained to do that. So, like a human being continuously learns and you continuously adapt. So, if you learn something today and you get experienced at it, in 3 or 4 years' time, your response may be slightly different because you've got experience. And I'm sure we've all seen that, when we've been to school and university and bits and pieces, where the textbook says one thing, but then when you actually go into the real world, there's shortcuts, there's better ways, or there's things that you don't actually need to consider because you've got that experience and you know roughly how things are going to go. So
Mm.
you will adapt. Whereas with an AI model, once it's trained, it doesn't learn anything new. It just will continue based on what it's learned.
Same.
Um,
Okay.
so it doesn't continually learn at this point. I'm sure maybe we'll get adaptive machine learning models in future, but as
Mm.
it stands today, once a machine has been trained, it doesn't learn anything new, even if you present it with new data.
I
And that's
see.
something that's important for businesses to know, that because often, again, one of the reasons why we're in business is companies will spend a lot of money, invest in some software, and they think, right, it's there, we don't need to touch it ever again. And with AI, it needs that continuous investment because legislation changes, customer attitudes change, and there's a lot of change. And if you don't adapt your models to those changes, then your AI solution eventually won't work, or
Mm.
won't be fit for purpose. So it's something
Mm.
that businesses do need to be aware of, that if they're venturing into AI, it's something that they need to incorporate as part of their business moving forward. And it's not just something you buy once and it's good forever. Um, yeah,
Keep adapting to it and improving it
yeah,
as it goes.
absolutely.
Yeah,
Yeah,
yeah. Okay. No, that's great. Thank you for your insight on that. That's really interesting. And one of the things I wanted to touch on as well was your passion as well in renewable energy. I heard something on
absolutely.
the news recently about how renewables are going to be very, very linked to technology, the way that technology can, help protect the environment. So, and your house is all geared up, isn't it? Explain to us a bit about your
That's
house.
right. So I started on this journey quite a while ago. So one of the first, and I got into this partly, for responsibility reasons. I think it's the right thing to do, but the main driver was the economic reasons. So I bought a Nissan Leaf probably 10 years ago, and that was, even though people say there's not enough chargers now, back in the day there was even less. And they
Okay,
weren't
yeah.
and they weren't working as well as they do now. But that being said, it was a lot cheaper to run an electric vehicle, and the costs of that car, servicing was incredibly cheap. I just needed to pay for tires and screen wash and wipers. That's it. Whereas all the combustion engine vehicles I had before, you have to pay for brakes, exhausts, air filters, servicing, and there's a continuous cost. Whereas with an electric vehicle, it fundamentally was just cheaper to run. And even with the advent of energy prices going up, in my experience, it's been still cheaper than fuel. Um, but by the by, it was so economical that eventually I was able to upgrade to Tesla. I've got a
Nice.
Tesla Model 3. But when you start driving an electric vehicle and you think, okay, well, I'm spending more money on electricity because I'm charging my car at home. How can I offset that? So then you start looking into
Mm,
things like solar. So then you can
yeah.
generate your own energy and use that to put into the car. And also, it's fundamentally a nice feeling knowing that you're charging your car from the sunshine
Yeah.
falling onto your
It's
house.
pretty cool, isn't it?
Yeah,
Yeah,
and it's
yeah.
clean, and you
Love
know where
that.
that energy is coming from. So there's that. And then
And it's
also,
free.
yeah, and it's
Well,
free.
once it
Well,
pays for
yeah,
itself.
you pay for the solar array, but
Yeah.
eventually,
Mm,
if you have it long enough and you live in the same place long enough, it effectively becomes free. And the longer it's on your home, and also the more you
mm,
use it as well. And one thing that's I found since having solar installed at my property is it's more economical to use the solar that you generate than to buy it in from the grid. Um,
mm,
there are schemes where you can sell it back to the grid, and depending on the size of your system, sometimes it is more economical to sell it to the grid because everyone's energy consumption is different. So if you're not a big user of energy, it can be more economical to send it to the grid because it's energy you're never going to use anyway. However, as a high
mm.
user of electricity like myself, it's more effective to consume it rather than send it to the grid. So there's different arguments there, but yeah, it's a nice feeling knowing that you've got this energy from the sun and it's clean and you know where it's come from and it's going directly into your car, and it's all good. And running your home as well, you're cooking, you're cleaning, everything, it's all done by solar. And not only that, once you've got the solar, it's using the energy when the sun isn't shining, and this is where batteries come into play. So we've got home energy batteries that will charge from the sun. Well, they charge from the grid at
Mm.
night, but if there's surplus solar energy, it will charge up those batteries, which basically means we can run the house off grid for the most part. So especially in the summer months when the sun goes down, we're still using the energy that was generated, surplus energy that was generated during the day, to coast through the night until the sun comes back up the following day. So
Amazing. That's
yeah,
pretty cool. No, thanks for
yeah,
sharing. It's really
yeah.
really cool to hear about how you've got it all, geared up with the solar panels and for your electric car. It's yeah, I do think that renewables is going to be like quite a big sector that will use technology as well going forward.
Very much so, yeah.
Yeah.
And because all of these things are smart technology as well. So they've all got their own apps, they've all got their own APIs, and you can do some quite clever things. So with the chargers, for example, on my home, they look to see if I'm exporting energy to the grid automatically. So it's not something. I had some chargers before that didn't do that, and it was one of those panic situations where you think, "Oh, I'm exporting energy to the grid. I best go and plug in the car." Whereas now these smarter chargers will detect when energy is going to be exported to the grid and automatically put it into the car. And
Oh, that's
that's been a
clever.
real
Mm.
game changer, because you can just literally, the technology gets out of the way, in the sense you can just come home, plug in the car, and then just forget about it, and the technology does the right thing. And that's just on a domestic scale. I think,
It's really smart.
well, yeah,
Mm.
thank you. Yeah, when you look at it on a national scale, you know, the demand response for the grid, and being able to force discharge a battery when there's more demand on the grid, and so on and so forth. So, and that's coming to cars, or that will be coming to cars in the long run as well. So you can actually, send energy from your car into the grid, and so on. But all of these rely on smart technology. And one of the things I found in my home, because it's not just the solar panels and batteries, we've got other devices that will. So I've got Nest thermostats in my home, and they detect when the house is warm enough, they turn off the heating, or when the house drops
Mm,
below a
cool.
temperature, it automatically turns it on. Whereas thermostats of old, you had to literally program it and say, "Oh, come on between 8 a.m. and 11 a.m., then turn off, then come back on at 4." This will just keep the house at a nice constant temperature, just by actively monitoring the temperature of the house and using the energy. When your house dips below a
Nice.
comfortable temperature.
Mm.
Um,
What more efficient can you get? It's all about efficiency, isn't it? So
Absolutely, absolutely.
yeah.
And a lot of these renewable devices coming, or that are coming in on the market, all will need apps, and all will need to have that value add by having these smart features on them. And this is where I believe we can add value by designing and implementing software solutions that make these things smarter, and just react on demand, really. So when they're needed,
Mm.
they will switch on, and when they're not needed, they'll turn off. And yeah, I
Make
think
our lives easier, that's what it's all about,
very
isn't
much
it?
so.
And better for the environment.
Yeah,
And you have a very user-friendly approach, don't you? So it's all about like not having to learn how to use something. It should be able to be picked up and just be used with ease.
absolutely. I think the
Mm.
kind of solutions we like to develop are where, if you need a manual to look after, or to actually understand something, you've kind of gone the wrong way.
Yeah,
Sorry, my dog's trying to
that's
get
no
in.
idea. No,
Um,
it's absolutely
Yeah,
fine.
yeah. So things should be intuitive and easy to understand, and the best technology kind of works, and you don't even have to think about it. Which is why, again, we've got the smart thermostats, the smart car chargers, the smart batteries on the house. Um, I can see the data and interact with it if I want to, but for the most part, I can just forget about it, and it just manages itself, and does its own thing. And even outside of the renewable space, when we're designing user interfaces for customers, and putting in solutions, we try to have the minimal steps needed to achieve the end result, um, and
Mm.
really try not to over engineer a solution with things like, what if this happens, or we look at the core use case and make sure that the user isn't having to do extra steps just because there's this one edge case that might happen. Um, so there's ways you can build systems to have those exceptional situations managed in an intelligent way, that don't affect the 90% of day-to-day use of a given system.
You're not overcomplicating it. It's nice and clean, it's nice and simple and easy
Absolutely,
to use for the customer, isn't it? So
absolutely.
yeah, that's great. And what advice could you give to those that are perhaps in the industry or even looking into the industry when it comes to developing applications?
Mhm.
Just advice and tips from yourself really throughout your career, what's worked best for you in terms of learning technology?
Sure. Well, from a software construction standpoint, I would say make sure you've got some sort of CI/CD process in place. I think that's a given now, but you'll be surprised there's some businesses that don't have that. And to be fair, that's reasonable, because if your core business isn't software development, it may not be obvious that, there's I think it's obvious you need a developer, or someone who can actually build the software. But I think the actual management of that software and making sure it's tested and is what they call extensible, which means you can extend it and add things later on. So designing the actual architecture of the software that, whilst keeping it simple, making it flexible enough to be enhanced in future. Um, and that's generally a good approach. Um, Also, being aware of technologies that are not just browser-based technologies. So one thing I see in the industry, there's a lot of hype around JavaScript frameworks and running things within the browser, which is great. I mean, there's a lot of value to that, and a lot of organizations do run incredibly well off browser-based applications. But there's often a strong bias towards that. And with smart devices, if you're using other languages and frameworks, you can interact with hardware. And so let's say if you're designing a smart vehicle charger or a smart kettle or anything like that, these things aren't going to be running web browsers, but they're still going to be producing data and offering features that could be interacted with over a network. So don't always consider only building for the web. You might want to build a native application, or some other sort of server-side application that's done in a way that can.
Multi-device, it can be,
Exactly,
different applications,
exactly.
different devices. And
Yeah.
what about when it comes to sort of cyber security as well? Has that been an element that you've got to be very much aware of when you're developing your applications? And
Yeah, very much
getting more
so.
and more
Yeah.
hot on that, aren't they?
Yeah, so I would say
Mm.
security is at the core of everything these days. So whilst it's not a very exciting topic to talk about in terms of features and functionality, is incredibly important. And
Mm.
every communication that goes over any sort of network really should be done secured, even if you're just using it in your home. um,
Mm.
you don't want to be vulnerable to potential cyber attack that can control a device in your house just purely because it wasn't secured. So
Mm.
yeah,
Anything can be hacked into, can't it? If it's on the
well,
IP network sort of thing, then you can access quite a bit, can't you?
yeah, within
Way of getting
reason.
in.
And often, if it's within the home, so I think it's a really unlikely scenario where someone will just hack into your house and take control over all of your devices from a remote location. But I think it's possible to maybe download some nefarious software from a dodgy source, or even a legitimate source. There's phishing attacks and things like that go on, that will then extract data from devices on your network. So let's think of a hypothetical example. You could download a free game or something like that on a device. But if it's aware of smart things in your home, like your lights, or any locks you might have, or any devices, it can think, okay, well, based on this pattern of behavior, you're home at these times and you're away from the house at other times. So that
Ah, I
can kind of
see. Okay.
infer information, um,
Mm.
and through other devices it can infer your GPS location. So by having security even for devices where you think, well, it's not going on the internet, it doesn't need to be secure, it does need to be secure, because people can
I've
take
never
that
thought of
information.
that.
Yeah, it's like a Trojan sort of
Mm.
attack that could go on. So
I
um,
just
and
think more for sort of large organisations where perhaps it's a sort of a threat to the national security if it's sort of a rail or road or
yeah,
but obviously in people's homes it's just as much as a threat if they can determine when you're not in the house because
yeah.
then they can potentially go and take something from your house.
Exactly, or not only
So
that,
yeah,
even get hold of data. So if, let's say, you store your passwords on a particular computer system, and
yeah,
that
mm,
they can get the keys to the kingdom, so to speak, through that. So it's
yeah,
important not only to make sure data is transmitted securely, whether it's a public or private network, but also appropriate use of encryption, especially when it comes to sensitive data, such as passwords, user accounts, and things like that. Um, the safest option, of course, will be to literally encrypt everything. And whilst that's makes sense, sometimes there's things that are just in the public domain that you don't need to encrypt.
Really
You
too.
know,
Okay.
exactly. So it comes on in terms of balance, but I think anything in terms of user sensitive information or access credentials and things like that, they absolutely need to be encrypted, as well as if there's any transmission going on over any network, it needs to be encrypted. Absolutely.
Okay, amazing. No, thank you so much. It's really interesting to get to know yourself in terms of like the technology that you work with and that mobile application, that aspect of what you do, you know, on iOS and other tech as well, the mobile applications that you've developed and yeah. So if people do want to have a chat with you, what's the best way to get in contact? You have obviously a LinkedIn page, don't you,
Yep, they can get
with
in
your
touch via.
portfolio on there?
Thanks, Emily. Yeah, they
Mm,
can get in touch via LinkedIn. They can also visit my website at inconnect.co.uk, or you can go to www.inconnect.co.uk or go to the same space. Or they can drop me an
Inconnect.
email at gavin.olukoju@inconnect.co.uk.
Amazing. That's lovely. Thank you so much for joining the podcast today.
Thanks, Emily.
And we'll
Thanks very
speak to you
much.
soon.
All
Yeah.
right,
Have a
take
good
care.
one.
Speak
Take
to you soon.
care.
Thanks. Bye.
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 Bye-bye.